Okay, welcome back for our final presentation. Jeff Rice, a Seattle-based sound artist, will describe the sounds of the Pando aspen grove, which is by mass the largest tree on Earth. So, Jeff?
And let me grab my little clicker here. Thank you for the opportunity to speak today, and also thanks to my co-author Lance Oditt of Friends of Pando for his advice on the Pando forest and for his contribution to the recordings. This project began with a question, what is the sound of one of the world's largest organisms? And I'm speaking of the Pando aspen grove, and when I say single organism, that's what I'm talking about. This aspen grove of 106 acres is actually a single tree that came from a single seed, and it was first described in 1976, and it was confirmed to be a single tree via genetic tests in 2008. And here are some basic facts about Pando. It's 106 acres in size. It weighs over 13.2 million pounds, and that's dry weight. It weighs a lot more when it rains, when the roots pick up water. And it's one of the world's largest organisms of any kind. And it's clonal, as I mentioned. And what look like individual trees are actually branches, and there are 47,000 of them extending from a single root system. And if you see all those little individual things that look like trees, those are actually just branches. And the entire thing is an organism. And the age is about 9,000 to 12,000 years old, roughly since the end of the last ice age. And so why record at Pando? And I think from an artist perspective, there are many different reasons. I've been recording sounds of nature in the West for approximately 20 years, and I've always loved the sound of aspens. And Pando also just, it's aesthetically interesting, but it also offers all kinds of intellectual challenges about how could something so large with so many parts be a single organism, and it poses questions about identity, and the size of it poses questions about space, and the age poses questions about time. So it was interesting from an artist perspective, and from a bioacoustic perspective, sound is also a baseline from which to gauge environmental change. And part of what I do in my work is I record sounds and archive them on the Acoustic Atlas at Montana State University, where we document environments and preserve the sounds for posterity. And as far as we're aware, no one has done any comprehensive bioacoustic surveys of Pando. And I first visited Pando on assignment for the New York Times Magazine, where I was sent to record the sound of the leaves for the Voyages issue. And that was exciting. It was the first time I'd been there. And after doing that, I realized I really wanted to go back. I wanted to learn more about Pando. And so I had a chance to do an artist residency for the group Friends of Pando in July of last year. And I made all kinds of recordings from all different perspectives of the forest. And you can get a good sense of, those are all branches right there. Not individual trees, but just branches. And so I recorded all elements of the forest. So, what does Pando sound like? And the first place to start, usually most people recognize the sound of the leaves. And I'll see if this actually makes the sound go. This is probably what you think about when you think about aspen sounds. So it's this nice, staticky, calm, white noise, almost like rain. And in a way, Pando is named for this sound. All aspen trees, the scientific name is Populus tremuloides, which essentially means trembling people. My Latin is not very good, but the name quaking aspen also, represents the shaking of the leaves in the tree, and the way the leaves tremble and the tree bodies sway in the wind earned Pando the nickname trembling giant or quaking giant. So, it's not named for the sound per se, but this trembling creates that interesting sound and those vibrations. And this is another sound that those leaves make that's quite a bit different. And I'm just going to play a little bit of that for you right now. And this low rumble is made using a hydrophone, similar to this one right here, which was placed in connection with Pando's root system. And what you're hearing, I think, is the sound of millions of leaves in the forest vibrating the trees and passing down through the branches down into the earth, essentially, creating this wonderful low drone sound. And this was recorded during a thunderstorm when the wind was quite high, and you can, every once in a while you can hear a little bit of the thunder coming in through the hydrophone as well. But this is basically the vibrations of the tree and the vibrations of the entire organism, really. And it's an interesting thought. If Pando is the largest organism, or one of the largest organisms on Earth, is that one of the largest sounds on Earth? So I can just show you a picture of the roots, just to say, like, what does that even mean when we're recording Pando's roots? This is where we put the hydrophone, which is inside of this tree cavity. And so we were able to actually connect with the roots that way. You can see right there. And I'll just skip forward. But so essentially, what does Pando sound like? It sounds like the entire soundscape. It sounds like all of the interconnected sounds in the entire Pando forest. And we're really excited about the chance to hear this subterranean soundscape as well. So, thank you. Oh, and I'll just say thank you to our supporters, Friends of Pando and the Acoustic Atlas.
You can stay right here for questions. Okay, well, thanks, Jeff. So I'll start us off with a question. I know you mentioned that you're kind of preserving these recordings for posterity. Is there any scientific value to those recordings as well?
Well, there certainly is scientific value to all bioacoustic recordings, and I am not a scientist, and I'm not looking at it necessarily from that perspective. But it tells you so many different things about the environment. It tells you about the species that are there. It tells you about the health of the environment, and it's a document of the environment as things change due to climate change and habitat loss. The sounds change along with habitats. So from an ecological perspective, there's a lot that you can learn by doing a bioacoustic study of any environment, really.
I have a quick general question about the organism itself. I'm assuming there are other aspen groves. Are there any that are comparable in size or close to that size?
So there are, of course, aspen groves all over the United States. It's one of the widest ranging tree species. And there are many large ones. I don't know how others compare to Pando, but I do know Pando is the largest. So it gets the distinction of being the largest tree. Bigger than the sequoia, bigger than everything, yeah.
It's so amazing. Thank you for that. Did you want to ask anything,
I don't know if I missed it or not, but if you try, I know somebody's doing this, and maybe it's you. Try to put a hydrophone or a microphone like in the tree, the same way you sort of tap maple syrup to get the, kind of the xylem and phloem. Have you done that at all with Pando or thinking
No,
about it?
other people have done more scientific studies of the trees using accelerometers, and nothing in Pando, but vibration of trees is a growing field of study, and there's always more to learn, and this is sort of a different way of recording a tree.
We have one more question. This is from Jennifer Walter of Inverse. She's asking, do you have any plans, or are there any plans for scientists to analyze exactly what is being heard in the root system?
So there's nothing specifically in the works for that. This was essentially a discovery on a 3-day expedition to Pando, and it was almost really sort of a surprise that we got this sound. We weren't expecting it, and so I thought it would be interesting to come to the Acoustical Society and present it to some scientists who can actually maybe do some scientific research on this type of thing. I'm just kind of bringing it to people's attention that the subterranean soundscape is very rich at Pando, and that Pando is very resonant. And now, to say that it's the roots themselves, we can't, say that exactly. We know that we were in contact with the root system, and we know that the tree vibrates. We know that it's the vibration of the tree in contact with the roots, but it's hard to say what that means, whether it's like a combination of the sounds of the earth vibrating or the specific roots, but it's certainly interesting. Okay. All right. Thank you.
Okay, thanks, Jeff. So that concludes our press conferences for the day. We will have high quality recordings available, and we will connect you with any of the presenters if you email media@aip.org. And I think that's it. So thanks for tuning in.